Okay, this video is going to be a demonstration of another example of using the product rule and the quotient rule together in the same problem. And I wanted to point out a couple extra things that I didn't include in the last example of the joint product and quotient rules. You'll notice that in this particular example, I've got a couple things that are different. First of all, I don't have anything written as the base. Remember, it's log base whatever of the number itself. When you don't have a number there, you just assume that it's base 10. Okay, that's because our calculators are set up to use base 10. So I'm just not going to write it in this time, but sometimes you'll see it written without the actual base in there. Again, just assume that it's a 10 when it's like that. Then you're also going to notice that I've included a little table off here to the left-hand side. Again, these are all written in base 10. So log base 10 of 2 is 0.301. Log 3 is 0.477, log 5, 0.699, and log 7 is 0.845. I'm going to do that because I don't want to have you use the calculator for this particular demonstration. We're going to see if we can express this or unpack this logarithm using both the product and quotient rules and without using our calculators, okay? So let's see what we would do here. So we'll call this our first step. What's our second step? Well, what I'm noticing right off the bat is that this is a quotient, right? It's log base 10 of 3/14. So I'm going to use the quotient rule to unpack this. I'm going to say log base 10 of 3/14 is the same thing as saying log base 10 of 3 minus the log base 10 of 14. So I've given the numerator minus the denominator. Remember, that's how you unpack that. What I'm noticing also, though, is that 14, I don't have that over here, so how am I going to figure it out? Well, I do know that 14 could also be expressed as a product, can't it? It can be expressed as 2 times 7. So let me just write that in here. And then I'm going to be able to unpack this as an example of the product rule. So let me just do my next step. I'm going to say log base 10 of 3 minus, and I'm going to put this in a bracket because I want to keep this a little bit separate for right now. It's like saying log base 10 of 2 plus log base 10 of 7. Okay, and then that makes sense again according to our product rule. And notice that I put a parentheses around there because I could distribute the negative if I needed to. But I'm not going to need to do that, and I'll show you why. I already know what log base 10 of 3 is according to my chart. It's 0.477. I know that in my parentheses, log 2 is actually just 0.301. Log 7 is 0.845. And I don't need to distribute that because I can do what's inside the parentheses first. Now I just happen to know when I add these two guys together, and again I don't need a calculator to do this, I'm going to get 0.477 minus this sum, which is 1.146, right? Then I'm going to subtract this, and again I don't need a calculator to do that. It's going to be a negative 0.669. Now there's my answer. Let's see if this answer makes sense in the context of our problem. Sorry about that, there it is. Let's see if that answer makes sense in the context of our problem. So let's do just like a little mini check here to see if we're in the ballpark. Remember that my problem is basically saying log base 10 of 3/14 is equal to something. We wanted to find the exponent that will make this true. So log, and I'm just going to write the 10 in here for convenience sake so that you can see it. This is basically saying, when I change it to the exponential form, it's like saying 10 to the x is equal to 3/14. Again, let's intuitively see if that makes any sense. I happen to know that 10 to the negative 1 is 1/10, and that's smaller than 3/14. I happen to know that 10 to the 0 is equal to 1. So what I want to find is what 3/14 is. So that means that 10 to some x is equal to 3/14. Now what does this tell me? That tells me that my x is going to be somewhere between 0 and -1. So it's going to be a negative number. And when I look at the answer that I got, -0.669, intuitively that makes sense. So really what I have said here is that 10 to the -0.669, sorry about that, I was a little bit off the camera. I'm saying that 10 to the -0.669 is equal to 3/14, and that does make sense. Okay, I hope this helps you. Good luck with this videos.